Okay, now let's look at few of the elementary properties of the expectations. So these properties are obvious. So the first property is that if random variable is greater than 0 or if random variable is non-negative, then expectation of that random variable will also be non-negative. Random variable is non-negative, that means what does it mean? That whatever the experiment outcome, those outcome is getting mapped by this random variable such a way that it always takes the value which is greater than equals to 0. Then what we are claiming is that in this case the expectation will also be greater than equals to 0. So we can easily look at this from the definition of the expectation. So what we are saying, that whatever the value random variable is taking, so random variable is taking this small value x, so all these values are greater than 0, so this will be greater than 0. And we know from the basic axioms of probability that probabilities are non-negative, so this will also be greater than 0. So if you do the summation of this, the expectation will also be greater than equals to 0. Now the general case is the second property of the general case of the first property is the second one. That what it is saying, that if the random variable is in between the value from a to b, then expectation will also be in between from a to b. Let's first of all understand that what does it mean that random variable is from taking the value from a to b. So you carry out the experiment, there will be some outcome. So irrespective of outcome, what random variable is doing is that mapping all these outcome to a number from a to b, all these outcome to from a to b. Then what we are claiming is that the expectation value will also be from the number for expectation will also be from lie between a to b. So yes, the expectation is nothing but the average value of the random variable. So you can think like this also, that average will not go beyond this point, right? Because if this is our average and we have this value that is the least value a and the highest value b, then the average will be somewhere between a to b. So you can think like this also, or maybe you can proceed with this definition and you can look at mathematically that if random variable falls in between some ranges, then the expectation will also be somewhere in this range. Coming to the third property, that if c is constant and if we take the expectation of this constant, then it will give you the same c, same constant. The expectation of constant is constant and that will be same number c. How we can see? So if c is constant, so if this random way, so what kind of, so let's suppose we can take a extreme case where random variable x is mapping all those outcome to one number that is at 1, right? So what that is at c, right? So if you look at the PMF of this, so what this is random variable is taking some value c, right? And this, so you carry out the experiment, you will have the outcome, and the random variable is mapping all these outcome to one point at c, right? So here we will have the probability 1. So what we are trying to find, we are trying to find the expectation of this kind of random variable, right? So the you can go through the definition, right? So if you look at the definition, so random variable is taking the value c, right, times with the probability 1, so the expectation will be c. I hope there is no confusion in these elementary properties.